Okay, question 14. The graph below shows a parabola with the equation in the form y is equal to x plus a squared plus b. So that's like you're completing the square type form. It's shown here, which is quite helpful seeing it. And the axis symmetry they're actually giving you is -5. Okay, so there's our axis symmetry up there, -5. What is the value of a? Now you should just know off the top of your head that a is going to be equal to 5. Okay, now again, have a guess. It's going to be 5 or -5 because we should know that the number in here moves the graph left or right. Okay, this number at the end, in fact, I'll use a different colour pen for that. This number at the end moves it up and down. Okay, so sometimes I'm not great at remembering all these things, and I like to try and think of a way of working out why that's the answer, or just even a way to check. Okay, so the first thing I always like to think on is, well, what is y is equal to x squared? Okay, there's y is equal to x squared. Okay, if I move that to the left or right, say move over here, and say that's -5. Okay, that means when y is equal to 0, x is equal to -5, and that's the minimum turning point, isn't it? Okay, so if I said that y is equal to x plus 5 squared, I'd be saying, well, is that correct? Would that be correct? Okay, well, if y is 0, -5 plus 5 gives me 0. So yeah, okay, that seems okay. I'm happy with that. The other way of thinking about it is saying, well, at the turning point, this bracket has to equal 0. So you could say, well, x plus 5 has to equal 0, and then rearrange that, that gives you x equal to -5. So I like to think of little examples that would make me think, yeah, okay, that's how it works then. So it seems counterintuitive. We always think going left means going negative, but for these ones it's the other way around, and that's why it's the other way around, because when we change the formula here, we move it to the other side, it becomes the opposite sign. Okay, so have a guess. Okay, it's going to be 5 or -5 because that's how much it's moved to the left. Okay, because a normal, just a standard y is equal to x squared graph would be in here. Okay, touching that's terrible. Sorry that. Would be in. I've done again. It's actually harder than it looks. Would be kind of in here. Okay, but we moved it over 5 places, so it is +5, and I've just explained why that is. Okay, so a would be 5. Okay, so yeah, +5. Right. So that's moving left and right. Let's just get rid of that now. Obviously, it's been moved up as well. You see, there's a bit here, but that would be the B section, which we don't know anything about just now. Okay, looking at the axis, I mean, it's probably going to be about 3 or 4 or something if that's 8. Okay, let's have a look. The next question says we've got a point -38 to calculate the value of B. Okay, so how much has this graph been moved up by? Well, we know that our equation of the line is y is equal to x plus 5 squared plus b, and we know that when y is 8, x is equal to -3. Simple as that. So -3 plus 5, that's 2. So 8 is equal to 2 squared, which is 4, plus b. So b is equal to 4. And again, I'm looking at the diagram and thinking, yeah, that seems about right. Okay, so 5 and 4. On the marking scheme, yep, 1 point for that. On here, you're getting a mark for substituting in, and then a mark for solving. Okay. It's not the hardest question, really, when you think about completing the square. You're just thinking that b is moving it up or down, and this a is moving it left or right. Okay. If a is positive, it's moved it to the left. If it's negative, it's moved it to the right. But over here, as I've shown, you could try and say, well, why is that? And it's like this. Just think of this little example here. If I move this this y is equal to x squared over to the left, suddenly its turning point's at -5. So when y is 0, x is -5. 0 minus 5. How do I get that bracket to be 0? -5 plus 5. Okay. So try and think of that, yeah. But honestly, just change the sign of that, and that's your axis of symmetry. go back the other way. If that's your axis of symmetry, change the sign, and that's what the value of A should be. Okay. Cool. So that's a little bit of that's probably not the hardest complete the square question they've given you. They could have given you. So I think we probably got off quite lightly there actually. So far, I would still say from my money, hardest question possibly being the angle chasing. I think there's a wee bit in that. I think finding out, remember all your rules. I'd say that's probably the trickiest one. Okay. Yeah, tricky. And here again, I'm not sure what's hard about that. Substituting values into the equation, not difficult at all. Okay. Right, question 15. Let's go a little bit. Last question. And again, please feel free to leave any comments if there's anything you'd like done differently, or if you would like a video made up. I'm more than happy. This is kind of me really just practicing, getting used to the syllabus and getting used to trying to explain things. It's quite hard to put things into words for new starts. So yeah, anything you want, give me a shout, all right? But yeah, last question. So in the diagram below, TS is parallel to QR, so we can see that on the diagram, right? There's TS and there's QR. So I'm just going to delete that. TS is 5, that's on the diagram. QR is 7, that's on the diagram. SR is 2.6, that's on the diagram, so I don't need any of that information. Calculate PS, which is shown as X. Okay, cool. So, solve for X. Now, the first thing I would do here is just redraw my diagram. Okay. So there's X and there's 5. Also, there's a bigger triangle, isn't there? This is X plus 2.6. And this is 7. Now again, this is actually, okay, from my mind, a little bit of trickiness here because we're obviously, when you see these two shapes inside of each other, you should be thinking similar shapes. Okay, so I've instinctively just gone and drawn the two similar shapes, which is to say I've drawn this triangle, which is here, yeah. And then I've gone and drawn the bigger triangle, which goes from P all the way up to Q. Okay, goes all the way like that, down. Okay, so I've drawn these two triangles. So they're similar. This angle is going to be the same for both of them. Yeah, mathematically similar triangles. So that's maybe the first problem, is that they're trying to get you to identify similar triangles. When you see two shapes that look similar, I suppose it's not rocket science, is it? Okay. So now we're thinking, well, how do we work out what X is? Well, when we usually do our similar shapes, we usually think of new and old. Now in this case, X is on both sides, so it doesn't really matter what's new and what's old, so just pick new and old, okay? But again, with any kind of similar shape, work out a scale factor. Okay, so the first thing you should always think of, just do a scale factor. So I'd say new over old for this one is going to be 7 over 5. Okay, and obviously non-calculated paper, just leave it as a fraction, that's great. And that's probably going to get you some marks, okay? We'll check that at the end. I'm sure just working out that is going to get you something. Okay, so we know that's a scale factor. If we're going from here to here, if we multiply by 7 over 5, we're going to get final answer. Okay. So if I've got X on the left here, so I've got X, if I times that by 7.5, so I said X times, I'll use a dot for 7.5, otherwise with too many X's, that's going to equal, I'll just put this in the colour, that is going to equal this, isn't it? Okay, because I've gone, so for 5 we did 5 times 7 over 5 would give you 7. 5 times 7 over 5 equals 7. Okay, that was what our scale factor is. So if we're going from X to X plus 2.6, we're timesing that by 7 over 5 as well. So X times 7 over 5 is going to be equal to X plus 2.6. Now, let's rewrite this a little bit. X times 7 over 5 is the same as 7x divided by 5. Yeah? And that's equal to X plus 2.6. Okay. Now, 7/5 X and X. Now let's see if we can get these into the same kind of terminology. You know, it's just before we go any further, okay? So 1x is the same as saying 5 over 5x, isn't it? Okay, like I said before, one pizza is the same as 2 halves. Yeah? One pizza is the same as 3/3. Yeah. It's the same as 4/4. Okay. So I've just done this so that when I move it over, so I want to now get the x's to one side of the equation, it makes more sense. Okay, so I've got 7/5 x on the right hand side. I've got 5/5 x, and I'm going to take that away, aren't I? So I'm going to take away 5/5 x. Okay, and that's going to equal 2.6. So 7/5 take away 5/5 is obviously just 2/5. So that's 2/5 x is equal to 2.6. So then what does x equal? Well, let's move the 5 over. So I'm dividing by 5 on the left, so I'll times it on the right. So that's going to be 2x is equal to 2.6 times 5. I do apologise, I'm running out of space, big style here. And then to get rid of the 2, I'm timesing by 2 on the left, so I'm going to divide by 2 to move over. So that's going to be x is equal to 2.6 times 5 divided by 2. So what's that? Well, 5 times 2.6. I always think, what's 5 times 2? That's 10. And what's 5 times 0.6? It's going to be 3, isn't it? So that's 13. And then 13 divided by 2 is going to be 6.5. So x is equal to 6.5. I think we are dealing in centimeters. Okay, so I think that was probably slightly trickier than other questions. I'm going to have to wrap up quickly because my time is running out. So 3 marks. You're getting your first mark, like I said, for your scale factor. You could have gone either way. It wouldn't have made a difference. The second is when you're forming your equation. Okay, so you get your second mark for that. And then finally, just for solving the equation. So you're actually doing quite a bit of work, I think, to find the right answer. Pardon me, because you've got to rearrange it in such a way. So yeah, I think there's a wee bit of work in that. But if the minute you see similar shapes, if you just say, well, I'm going to write down a scale factor to get 1 mark out of 3 for just blindly doing a scale factor, brilliant. Okay, if you can form that equation, that's your 2/3 of the way through the question. Okay, so yeah, that was probably, I think that was tricky. That one and the finding angles question, probably the trickiest on the paper there. So yeah, that's us gone all the way through. Like I said, I hope some of that was useful. Sorry, things are a little bit messy. I've tried to talk through some of the subjects with little extra commentary, like in here with the graphs. And here again give different examples of scaling up the coefficients. Yeah, I think I'm hoping that's been really helpful. Okay. Big thing is just practice. National5.co.uk website has got loads of examples. The more you do, the better you're going to feel. Honestly, there's nothing to be scared about in these things. Okay, there's a few simple rules. It's not a massive syllabus. Really, it's just about practicing and getting some confidence and knowing when you're on the right lines, having that feeling of, oh yeah, I think this is about right, or oh, made a mistake, I'll come back to that. Okay, it's all about practice and confidence. Okay, but we've done loads and loads here, and I think as you go through and look back, you'll be like, oh, actually, yeah, that was quite simple. I could do that. Yeah, now I've seen how that's done. That's fine. And all these papers are so similar as well. So similar. Same questions dressed up differently all the time. So just keep practicing these, okay? Do little videos now and again and try and do a big paper now and again just to feel what it's like to go all the way through. Okay. But yeah, thanks very much for watching that. And yeah, hope you had a good one and good luck whatever you're doing. Alright, thanks. Bye.